Hello. Today we're going to learn how to solve more complicated trig equations than we have before, but we'll start with one that you should be used to. Solve for theta, where 3 times the sine of theta equals 2, where theta is between 0 degrees and 360 degrees, round to the nearest tenth. So I'm going to pause for a moment and let you start this on your own. Please pause the video. Hopefully you got at least this far. You divided by 3. You got sine of 3 equals 2/3. Sine of theta equals 2/3. You're trying to get theta alone, so that's when we break out the inverse sine. If we take the inverse sine of both sides, theta is left alone here. And then this we need our calculator for. So turn on your calculator, check the mode, see if it's in radians or degrees. We want degrees this time. We're going to do the inverse sine of 2/3. Most of you already got 41.8 degrees. But the question is this the only answer? We want all the angles between 0 and 360. That will give us a sine of 2/3. What we have to do to figure this out is think about where sine is positive. Sine is positive 2/3 in the first quadrant, which is why 41 was one of the answers. Sine can also be positive in the second quadrant. So we need to figure out this angle. The easiest way to get that angle is to do 180 minus your answer, which is the reference angle. And that will be an angle in the second quadrant that also would have a sine of 2/3. So we'll write down 138.2 when we round up. And here we go. On to the next one. The next question asks us to simply look at the difference between the original and this one. So if you look at this equation and the opener, the only noticeable difference is what comes after sine. This is sine of theta. This is sine of 2 theta. If you wanted to write this another way, you could also write this in parentheses. Both of these are included in what sine is taking. Sine is taking this angle, 2 theta, and getting out an answer. So what we need to look at here is not just the difference between the 2 theta and the theta, which we could probably make a pretty easy sentence about. We just say where the theta was before, 2 theta is now. But we need to analyze what this means for the restriction. When I talk about the restriction, I mean the fact that theta needed to be between 0 and 360. Well, if theta needs to be between 0 and 260, then how big is 2 theta allowed to be? Since 2 theta is twice as big as theta, if theta is allowed to be 0 for the minimum, then our new minimum is twice 0, or 0. So we basically multiplied by 2 here. Okay, so we'd say 0 is less than or equal to 2 theta, which is less than, okay, so if the max of theta is 360, then what's the max of 2 theta going to be? Well, you're just going to multiply times 2, and you've got 720. So we have new restrictions. It's that our 2 theta, what we solve for, has to be between 0 and 720. Now we have to actually solve the equation. What do you think the first couple steps would be? Go ahead and pause it and unpause when you're stuck. You should have gotten about this far. We're at the point where we isolated the sine of 2 theta. And now to get rid of the word sine, we need to take the inverse sine of both sides. That leaves 2 theta on the left and, well, whatever the calculator says on the right. This is actually the same problem as before. So before the calculator gave us 41.8, it shouldn't give us anything different this time. So that actually means that 2 theta is 41.8. Oops. That means that 2 theta is 41.8. And so that's actually not going to be the final answer for theta, but it is going to help. Okay. So we've got that 2 theta could be 41.8. Before you start dividing, I want to think about what else this could mean. Well, sines need to be, again, in the first and the second quadrant. So this is just like before, where 41 is represented here, and the next one, which is 138.29 is represented here. Again, nothing different than last time. But what is different than last time is our restrictions. Go back to looking at our restrictions up here. We got our restrictions by multiplying the original restrictions by 2, because if theta can be up to 360, then 2 theta can be up to 270. We are allowed to find angles all the way up to 270. I'm sorry, I keep saying 270. 720, all the way up to 720. But I don't think we're there yet. So we've got 41 degrees and 138 degrees. we're allowed to go all the way to 720. 720 means not once around the circle, but twice around the circle. Okay? So we've got both of our measurements for once around the circle, but we actually have to go again, right? We have to see all the angles that would give us this measurement for sine within the first 720 degrees. So how would we get this next one? Basically, we've been around the circle once, and we're going to try to go around the circle twice. These are known as coterminal angles, right? So how do we get from 41.8 to its coterminal angle? All we have to do is add 360. 41.8 plus 360 should be 401.8. And let's do it for the other one, 138.2. Oops, I did that wrong. Just 0.2, not 0.29. Plus 360. And we get 498.2. Now these are all of the angles that are between 0 and 270 that will give us this positive sine of positive 2/3. But remember, all this work gave us stuff that's equal to 2 theta. We still do want to solve for theta. That's still the prompt, solve for theta. So at this point, we're going to take this side and divide by 2, and we're going to take the right side and divide by 2. That means every one of these angles is going to be split in half in order to find the value of theta. So go ahead in your calculator, split all 4 of these angles in half, just divide by 2, and I'll do the same. Here are the 4 answers that I've gotten. Hopefully they match. I'm going to think real quick about how to check my answers. So if I check my answers, if I put them in the original equation, it should make a true equation, an equation with the same thing on both sides. So 3 sine, I'm in degree mode, of 2 times theta. If I pick any one of these, it should work. I'm going to pick 200.9, just to see. 200.9, end parentheses. And if that equals 2, which is on the other side of the equation, then it means I'm good. Okay, it did. So why didn't it exactly equal 2? Well, that's because we were asked to round to a tenth. So it turns out that 200.9 is not the exact answer. Otherwise, it would have given us exactly 2. But since we rounded, this is going to be not exact anymore. But it's close enough that we can definitely tell that we did this right. You could check for any 4 of these angles to make sure you did all 4 right if they turn out to be approximately 2. I'd like you to summarize the strategy we just used in your own words before you move on. So please pause the video, summarize, and then we'll do some more practice. Moving on to the next one, we've got 4 cosine of 3 theta equals 2. And the restriction is the same between 0 and 360 degrees. So start to solve this. And I also want you to figure out what the restrictions will be. To solve this, we're going to divide. And then we're going to take the inverse cosine. Okay, and at this point, we really do need to stop and think about our restrictions. So we're going to start getting answers when we put inverse cosine of 1/2 in the calculator, which, by the way, that's a special triangle, one with an x value of 1/2. So you can figure this out without a calculator. But anyways, I'll let you use it. So we need to figure out what the restrictions are. If the restrictions of theta is that it should be only up to 360, then what about 3 theta? Its restriction should be 3 times as big or 3 times as small. So I would write that the new restrictions are that 3 theta must be between 0 times 3 is 0 still. So between 0 and 360 times 3 is 1,080. Okay, so we're going to find answers between that when we go ahead and solve. Put this in your calculator. Okay, I told you it was going to be a special value, so you shouldn't be surprised when you see 60. So 3 theta equals 60 degrees. That's not the only one. We're going to have to think about cosine. Where is cosine positive? Right here, 60 degrees. Here's a place where the x value, the cosine, is positive. And here's the other one. This one can be found by doing 360 minus 60, because 60 is this reference angle here. That's just going to leave you with 300. So here's two answers so far. Theta could be 60, theta could be 300. But we're allowed to go all the way up to 1080 degrees, so we should continue on. All right, so our first pass around the circle, we have two values. Our second pass around the circle, we're going to have two more values. Two more coterminal angles with 60 and 300. But how many passes are we making around the circle now? 3. 1080 degrees is 3 passes around the circle. Every time we pass around the circle, we find two angles that work. Two angles that have a cosine of 1/2. So we found 2 in our first. We're going to find 2 more in our second and 2 more in our third. So I'm expecting to get 6 answers for this. I'm going to pause this and I'm going to find my 6 answers just by thinking about coterminal angles. Pause. Okay, there are my 6 angles between 0 and 1080 that should work for the value of 3 theta. But my final answer is not actually the value of 3 theta, it's the value of theta. So I'll divide everything by 3. And I'll get that theta is equal to a whole bunch of numbers. Okay, I hope you're good with that. When we flip to the back side, I'm just going to go straight through the answers. So the expectation is that you pause the video, do everything that you can without watching the video, and then play the video. Ready? Flip it over and pause me. Sine of 2 theta equals 5/6, so we'll take the inverse sine. We'll make sure our calculator is in degree mode, and we will get 56.4 when we round to the nearest 10 for the first of the angles. We need to think about the restriction. If 0 to 360 is the restriction for theta, then the restrictions for 2 theta will be double that. Okay, so we're going to find all the angles that are in quadrant 1 and 2, where the sign is positive, so quadrants 1 and 2, in the first 2 rotations of the circle. So 360 and another 360. We can expect to have 4 answers. Once we've got all those, we can just divide by 2, and we get all these as our final answers. These are all between 0 and 360, because when we found 2 theta, we found all of the angles between 0 and 720 that would work. On to number 2. Theta is between 0 and 1080 in this case, 3 times as much as the original restrictions, because this is 3 times theta. When we put this in the calculator, we get negative 30 out, which is kind of interesting. The calculator is giving you a negative answer because you put in a negative side length, and that's just what it does. But you need to kind of translate that answer into our restrictions. Our restrictions are these are positive. And so negative 30 is the same thing as positive 330. Okay, so positive 330 is really one of our answers. So I'm going to try this again. Positive 330 is one of our answers. That is in the 4th quadrant. Where else can tangent be negative? It can be in the 2nd quadrant. Basically, you need one x or y to be positive and one x or y to be negative in order for tangent to be negative. So these are the 2 that qualify. The coterminal angle, the angle with the same reference angle in quadrant 2 is 150 degrees. And then we're going to go ahead and add 360 to find the coterminal angles for the first 3 rotations of x. There are all 6 answers that I get for the first 3 rotations of x. Each are in the 2nd and 4th quadrants for the first 3 rotations. They're all less than 1080, and they're all positive. And now I'm going to divide everything by 3 to find the actual answer for what theta is, and not just 3 theta. And those are our 6 answers. If you plugged any one of them back into this, you'd see that it does equal negative root 3. We're going to take the inverse cosine, of course, and we're going to note that since this is 2 theta, our restrictions become up to 720. When we get this, we get out 180, which makes sense to me because the only place where cosine is negative 1 on this whole thing is 180. So there's not another answer within the first 360, but there is another answer within 270, within 2 rotations. The coterminal angle here will be 540, making the actual values 90 and 270.